I am going to cover the basic concept of machine learning, types of machine learning algorithms, and classification. What is classification, regression, and clustering? Then after that, I will cover classifiers, the neural network and deep learning, then activation functions, and at the last there will be the quiz session. So before going to machine learning concept, let's do some brainstorming exercise. So in this slide you can see there are 4 images, and these images are representing the various kinds of objects. So anyone can tell me that the first image is about?
So it's a dog and a cat.
It's a dog and a cat.
Okay. So first image is about dog cat, and the second image tells about that this is a fruit image, that is mango, and third image is about self-driving car, and fourth image is about this is a picture of set of fruits. So within a fraction of seconds human beings are able to recognize the object, and it is possible because we are trained person, we are trained by the teachers, we are trained by the parents, we are trained by the society persons. So within a fraction of seconds human beings are able to recognize the objects. So the question arises that if machine has to recognize the object, then what should be the process? That machine can be able to detect the object, machine can be able to predict the outcome. So is there any way that we can train the machines? Machines can be of any type, any shape. It may be in terms of software, it may be in the term of robots or any hardware device. So machine can be of any type, but we have to give proper training to the machines so that machine will produce good accuracy and good results about the prediction and about the recognition of the object. So this is the motive of machine learning, that what are the various ways where we are training the machines. So in this session we will discuss about what are the various ways where machine can be trained. So there are various types of algorithms, there are set of algorithms for it. So in this image, how self-driving cars make decisions. Self-driving cars means autonomous cars. Okay, there is no need of human intervention. So what are the various ways where these self-driving cars or autonomous cars run on the road? So because this is regarding the machine learning, so in this self-driving cars, how these cars make decisions, that what are the various objects in front of this self-driving car, and what are the various ways where in the night, if the light is dim, then how can this car will successfully run. So in this self-driving cars there are various types of sensors used. The first sensor is camera. Suppose in human beings we have eyes. Eyes are our sensors. When we are seeing any object with our eyes, so it means that we are capturing some object, and we have captured the object by the eyes and processed by our brain. So we have memory cells on our brain. So like that, how these self-driving cars make decisions. So for it we have sensors. The first sensor is camera. So there are various types of cameras are put at every angle of this car, so that cameras are taking the pictures, cameras are capturing the sensors. These are the high definition cameras. So these cameras are capturing the objects, scenes, and after that there is some processing. The processing can be from neural network, or the processing can be made from machine learning algorithms, so that self-driving cars can take the decision that car should be stopped, and when to slow the speed, when to do medium speed. And the second sensor, if we use radar detection, if we are using in self-driving cars, self-driving autonomous cars, then if there is a dim light, means there is not, light, there is dim light, then the radar detection will increase the intensity of light, or augment the light, and it will help to the cameras. So cameras will detect the object more efficiently, and the object or scenes will be processed by the some processing AI based algorithms. So how does a self-driving car see? With the help of reliable cameras, where the high definition cameras are placed at every angle. At least there is requirement of 8 to 10 cameras. Minimum requirement is of 8 to 10 cameras, and they are installed at every angle, so that a perfect or clear view of their surrounding can be captured. And to enhance the light, we are using the radar detectors. So radar detectors will augments the capturing power of camera sensors at night or whenever the visibility is poor. So this is an example of self-driving machine learning application. So like that, these self-driving cars can detect the object, and can detect the and can make the decisions that at which side these cars will be drive on the road. So this was the brainstorming exercise by which we will be able to understand that what is the purpose of machine learning. So means machine has to learn the data, that which type of data is this, is structured data or this is the unstructured data. Means machine will recognize the patterns of data, and with the help of patterns of data it will be able to predict the output. So the goal of machine learning is to understand the structure of data. Then after that there will be training will be given to the machine, and after when our machine or our model will be trained, then it will be tested for new data. And if accuracy of machine is 95%, so the research in the research field, we want to we want to enhance the accuracy. We will enhance accuracy till 99% or 100%. After that means and machine learning, what is the basic way of working of machine learning? That it will first parsing, it will use parsing concept. So it will parse data and defines the data in the form of structured. Then after that training will be given to the machine, then testing will be required. So till now I think we have easily understood that what is machine learning. Like as a human being are thinking, whatever human beings are thinking, can machine think? So this is the main task, that machine has to think, machine has to rethink about the scenes, about the things, and we have to give proper training to the machine. So what are the various ways where we can train the machine? So in the field of artificial intelligence, there is a concept of machine learning algorithms. So there are various types of category of machine learning algorithms where machines can be trained. So first, going to machine learning classifications or machine learning algorithms, we will understand the machine learning process, that what is the machine learning process. So the first is the data gathering. This step is regarding about the database or data set. Data set may be text, data set may be your images or unstructured data. The second step is that we have to pre-process the data, means we have to remove unnecessary information, we have to remove duplicate data, and we will find the missing data. If any data is missing from any column of data set, then we will put some value. We will put some value according to the requirements of data set. So the first step is that we have to take data set, and second step is that we have to clean our data. Cleaning means we have to find missing data, what are the missing values, then we will replace, and we have to remove the duplicacy of data. Then third step is that we have to choose the model. So this third step is regarding you want to choose machine learning algorithms, whether it is the supervised algorithm, or you can also choose unsupervised algorithm, or you can choose neural network to train to give the proper training of model. So third step is basically about which model you are choosing. You are choosing the support vector machine, or you are choosing the random forest, or you are choosing the decision tree, so or you are choosing the neural network. So we will try these all models and we will find the accuracy. Then after that we will say that this particular model or this particular concept is giving high accuracy or good accuracy for the data set. So there are different kinds of data set and different kinds of algorithms. So we cannot say that neural network is better than the traditional machine learning algorithms, support vector machine and random forest. Sometimes random forest is producing more accuracy than the neural network. Okay, so we have to test all the models for our data set. Then finally we will make the conclusion that which model is giving the best result in terms of accuracy, precision, and sensitivity, and F1 score. These four parameters are being tested for every model when we are working on machine learning algorithms. Then after that, when we have selected the model, then we will give the training. Okay, so we have taken our data set, we have cleaned our data set, we have minimized the redundancy, and we have find the missing values, replace the missing values. Then we have selected the models, that which type of model you want to choose for your particular data set. After that, training. So in the training process, the data set will be split into some ratio. Suppose I want to train machine with 70% training data and 30% of test data. After that, I will select 80% of training data and 20% of testing data. So here we have to use the mixed combination: 80%, 20%, 70%, 30%, 60% trained data and 40% of test data. Then we will find the accuracy for all the models. We have to do these things for all the models so that a clear accuracy can be achieved. Then if we are taking 80% training data and 20% of test data, then we will test the model. We will test the model of we will test our trained model. Okay, we will test our trained model. Okay, so that the accuracy can be achieved, accuracy can be computed. Then after that we will fed a new data to the trained model for the prediction, for to achieve the outcome. Okay, and after this is the last step, that where the our trained machine will predict the outcome. Okay, so the basic thing is that we have to give proper training to the machine. Machine can be of any type, whether it is a hardware or software. So we have to make some logics, and we have to use the machine learning algorithms, or we can use the neural network algorithms. We will train the machine, then we will test the machine, then we will fed at the last we will fed the new data input to the trained machine, and we will see that what is the accuracy, what is the prediction, whether machine is able to give true prediction, or machine is giving false prediction. And the basic task is that we have to enhance our accuracy of models. Suppose if we are using the random forest, that is supervised learning algorithm, and with the help of random forest the accuracy is 95%. And if you want to enhance the accuracy, then we have to use another trick, or we have to use some other logics, so that accuracy can be enhanced of our machine learning models. So the machine make will make more accurate decisions. Next. Then next is types of machine learning algorithms, that our machines can be trained with any one of these technique. So there are four types of machine learning algorithms, so that our machine can learn, and machine will be able to predict the outcome. So the first type of machine learning algorithm is supervised learning. The second is unsupervised learning. Third is reinforcement learning, and fourth is deep learning. So there are four various ways where our machine can be trained. So the first is the supervised learning. So all these there are four types of learning approaches to train the machine, and purpose is different. Supervised learning purpose is classification and regression. Supervised, if we are using the supervised learning approach to train the machine, then we will be able to classify, or machine is able to classify the objects, and machine will be able to predict the continuous outcome. Continuous outcome is part of regression analysis, and classification or categorization is part of classification problem. Classification means suppose you want to perform binary classification, okay, that this particular object is of class 1 or class 0. Class 0 means negative and class 1 is positive. If we want to categorize the objects in two parts, 0 or 1, then it is known as binary classification. If we are categorizing the objects more than one object, then it is the multi-class classification. In the previous slide we have seen the set of fruits. So there are 5 types of different kinds of fruits, so that will be the multi-class classification. And in the first image we have seen the dog cat image. So dog cat image, there are 2 objects, so it is also the multi-class classification problem. And if we want to predict whether it is a class 0 or class 1, then it is binary classification. And what is regression? Regression is the predicting the continuous outcome. So regression is used in to predict the share market price, to predict the financial model, and so on. So where we are predicting the continuous variable means when we are predicting the person's age, or we are predicting the growth of a person, or we are predicting some banking features. So regression concept will be used. And the second type of is unsupervised. But before going to unsupervised learning, in unsupervised learning, we have to give proper labels to each record. Okay, without giving class labels, we are not able to train the machine under supervised learning. Okay, so if we want to perform supervised learning to the machines, so we have to supply class labels for each record. Okay, so whether it is a class label yes or no, so we have to write on the dependent variable. Okay, we have to write the class labels for each record as a dependent variable. Okay, because we are predicting the dependent variable. Okay, so for each record of data set we have to put class labels. It is a 0 or 1, or it is in the form of no or yes, or whatever you want to make the prediction, good or bad. Okay, if it is a service kinds of things, then you can write good, bad according to your data set. Then then the training will be given to the machine, and after that testing will be testing process will be there. After that, new data will be given to the trained machine, and machine will be able to perform the whether it is a which type of classification and which type of data belongs. Then second is that unsupervised learning. In unsupervised learning, the application of unsupervised learning for different purpose. Okay, so the first application of unsupervised learning is clustering. Okay, suppose we have millions of records, or we have millions of data, and the ranges of and for to perform clustering, we have to define the ranges of data, and we want to put similar types of item in one cluster. Okay, suppose we have millions of data, and the range of data is 0 to 255. We have millions of data, and the range of data is 0 to 255, and we want to break these items or break these data items into different types of clusters. Okay, suppose we have initially taken taking the cluster is equal to 3, means we want to put these data items in 3 clusters, and every cluster has different range. The cluster 1 range is 0 to 50, and cluster 2 range is 51 to 130, and cluster 3 range is 131 to 255. So in cluster 1, the all the data items which belongs the 0 to 50 data ranges, that if the data ranges between 0 to 50, then they will be put in 0 to 50 ranges cluster 1. Okay, and the second cluster is about 51 to 130. So all the data items which belongs to these ranges, means 51 to 130, they are put in cluster 2, and the above the third category 131 to 255, the data items will be put on this third clusters, and from each cluster we are computing some measures. Okay, so measures can be mean. We can compute the mean. We will be able to compute the standard deviation, that what is the standard deviation of this cluster 1. So for every cluster, cluster 1, cluster 2, cluster 3, according to the ranges of data, we will compute the measures. Measures may be kurtosis, skewness, standard deviation, mean, what is the mean of cluster 1. So these types of applications are widely used in networking area, are widely used in image segmentation process, and banking sector also. The second task of unsupervised learning is unsupervised learning is for to train the machine. So they are linked with each other. Supervised is also linked with unsupervised. So the in unsupervised we are not giving the label in the training time. In unsupervised learning we are not giving the labels for every record or every data. In supervised learning we are giving the proper labels to train the machine, but in unsupervised learning we are not giving any label information that this kind of object or this kind of record. So there will be no labels, there will be no class labels 0 and 1. So in this type of learning, unsupervised learning, machine will itself try to find the best solution. Machine will try to find best solution, that what will be the best outcome. Okay, so we will set the number of iterations, so and it will always produce the best result. So the first application of unsupervised learning is clustering, and the second is dimension reduction. And what is dimension reduction? This is the very important property of unsupervised learning. Okay, suppose we have 100 of features. So 100 of features will take the memory. It will also take more memory, and it will also require more computation power. So in the dimension reduction, we will find the main important features. Suppose in any data set, if there are 10,000 records, okay, there are 10,000 records. If we identify the 1,000 main important features from the 10,000 features, okay, if we identify 1,000 main features from the 10,000 features, so it will require less computation time and it will require less memory. So in dimension reduction we are finding the main important features from the data set, or from the general features, okay. And the third one is that third category of machine learning is reinforcement learning. Reinforcement learning means machines will try to achieve best solution. Machine will try to get various path or various kinds of various kinds of strategy to find the best optimal solution. Okay, so only we will give the data and we will feed the logics, and after that machine will rethink that what are the various ways where machine is able to find the best solution. Okay, so it learns from the environment. In the third category is about reinforcement learning, where machine will learn from the environment. Means machine will think and rethink from the environment. So it will try to achieve best solution. Maybe it will find the best solution, and there is also chances that it will not find the best solution. So there are two types of reinforcement, positive and negative. And the fourth category is of deep learning. So in deep learning concept we are using neural network. Okay, neural network is like as a brain memory cells network, where the memory cells of brains are connected, each connected, okay, joined. So under the deep learning technique we are using neural network. So neural network is based on the concept of graph theory. Okay, so there are various kinds of deep learning models, the artificial neural network, convolution neural network, recurrent neural network, and the latest there are various deep learning pre-trained deep learning models, VGG 19, ResNet 34, and so on, mobile net inceptions. So these are the various pre-trained deep learning models where the number of layers will be increased. Okay. In generally ANN there are three layers: input layer, hidden layer, and output layer. Okay, and we can also make our models. We can increase the layers between the input and output. Means we can increase the number of hidden layers. Okay. So there are four types of ways where machines can be trained, so that machine will be able to perform the prediction, machine will be able to recognize the object. So with the help of these four types of learning, we are giving a proper training to the machine. So in machine learning, as already discussed, that in supervised learning, we are doing classification and regression. Supervised learning, if the machine is trained with supervised learning approach, then we are able to classify our objects, we are able to classify the objects, and we are able to perform regression analysis. Okay, so in regression analysis, you can see here there is a boundary line in black dots. You can see here there are boundary lines in black dots. Okay, and in regression you can see that there is only blue dots. Okay, there is a only blue dots, not green, not red. It means it is predicting the continuous variable. In regression, under regression analysis, suppose we want to predict the share price, future share price, or we want to predict the future forecasting. So we will use regression analysis technique under supervised learning. So regression analysis, it will predict the continuous variable, not discrete variable. Okay, so there is no range. Discrete variables, the ranges of discrete variable is 0 to 1. Okay, and the regression analysis is your continuous integer value. So under supervised learning, this is the classification, that you can see here two circles. One is red circle and another is blue circle. So in under classification, if we are using the supervised learning approach, so it will be able to classify the object, that which type of data belongs to which type of class. Okay, and the second is that unsupervised learning. In unsupervised learning we have mixed data. Okay, we have mixed data, and we have also different kinds of ranges of data. Then we will make the clusters. Okay, suppose the first cluster belongs to 0 to 50, the range of data. The data, these green data items are belong to 0 to 50 ranges. Okay, the blue one is 131 to 51 to 130, and the third types of cluster belongs to 131 to 255. Okay, so from each cluster we are computing the various measures that will be used for business growth, and that will be used for business analysis also. And third type of learning is reinforcement learning, where the machines will rethink about the environment, that what can be the better way. It will rethink, machine itself will rethink that what can be the better way that I can get the best solution. Okay, so it will learn from the environment, and there is a feedback system. And the fourth one is deep learning, that we have discussed earlier here. So now the term is that which types of algorithms belongs to which type of approach, which type of learning approaches. Okay, so neo based classifier, it is a basic classifier. It is based on the some probability. Number 2 is decision tree, and we will go in detail decision tree, support vector machine, random forest, because random forest came in year 2000, support vector came in 1980. So we will discuss about these supervised learning approach. Supervised learning and supervised is categorized in two parts: classification and regression. So under classification, maybe there are some algorithms which are used for both purpose, classification or and in regression. So under classification, there are various types of algorithms: naive Bayes, decision tree, random forest, support vector machines, and k nearest neighbors. KNN came in 1950. That is very old and have demerits. Under regression, we can use linear regression, neural network regression, support vector regression. Means we can use support vector machine. In regression analysis also, we can use decision tree regression, lasso and regression. Clustering approaches. Clustering approaches are very widely used for networking, wireless sensor network, image processing, and to identify the object location after segmentation of images. So the basic clustering algorithm is about k-means clustering, mean shift clustering, hierarchical clustering, and in the recent meta-heuristic based nature-inspired algorithms like as whale optimization algorithm, okay, and like as self-swarm optimization, okay, and colony optimization, particle swarm optimization. So these algorithms are very efficient to find the cluster heads in wireless sensor network and to do the to compute the measures. So now let's look about the real world applications of these machines, which are trained with supervised learning approach, unsupervised learning approach, reinforcement learning approach, and deep learning approach. So supervised is again categorized in two parts: supervised machines which are trained, which are using the supervised learning approach. Okay, so they are categorized in two parts: classification and regression. So in classification, you can classify the images, that this image belongs to which class. Suppose we have chest X-ray, and from chest X-ray we want to find the abnormalities, or we want to find some conclusion. So from chest X-ray we can classify that this chest X-ray image has pneumonia, or whether this with the help of chest X-ray we are able to find that this person has a particular disease such as COVID, or bacterial pneumonia, or viral pneumonia. Which type of pneumonia means which type of infections is carried by the person. Okay, so image classification, we can go towards also medical image classification. We can also perform medical image classification under supervised learning. Then fraud detection. Fraud detection means we can check whether this mail is spam or non-spam, it is genuine email or non-genuine. Okay, so fraud detection in security regions, we can apply supervised learning approach towards train the machines. Email spam detection. Okay, diagnostics means we are able to find the particular disease from medical images. Medical images can be of brain tumors. Okay, from brain tumors, if we apply machine learning algorithm to find the brain tumor from MRI brain tumor images, so the process will be same, that we have to take the data set of brain tumors, and then we will clean the data, we will segment the data and training the model, then test, and we will feed new brain tumor image to the trained machine, and machine will be able to find the disease, whether the person is having brain tumor or not, or in other field, in diabetes detection, in cancer detection, in COVID detection. Okay, and the second application is of towards regression analysis. So regression analysis means we are going to achieve business growth. we want to perform, or we want to analyze the business data. So we will also use the supervised machine learning approach towards the regression analysis for the business analysis. Then the second type is unsupervised learning, where we have previous discussed that this type of unsupervised learning approach are used for dimension reductions, where the main important features will be extracted so that it will be computation efficient and takes less memory. So the applications of unsupervised learning is towards to find the clustering head, or to find the city planning, okay, and face detection, text mining, and other fields. The third one is applications of reinforcement learning. Okay, reinforcement means it will also try to achieve best solution. What are the various? It will tries to explore that what are the various best ways where the machine can make good prediction or better prediction than the previous. And the fourth one is deep learning. Deep learning approaches are used to enhance the autonomous facilities. So deep learning are so machine supervised is totally traditional machine learning algorithm. So supervised, unsupervised are traditional machine learning algorithm, and these deep learning algorithms are advanced. Okay, so in deep learning we are using neural network. Okay, the difference between the machine learning, classical machine learning algorithm, and deep learning algorithm is about the variety of training processes. Okay, so in deep learning we are using the neural network concept. Okay, we are using the neurons concept, and the neurons will be multiplied by the input and weights and some bias. So the applications of deep learning are very vast. Okay, so again we are summarize the approaches. Supervised learning. In supervised learning we have set of data. Okay, so suppose we have set of data, these data are known as independent variable. Okay, so the dimensions of data can be in any form, whether it is a 10 dimension data or 20 dimension data, means the data set has 20 columns or 30 columns or 10 columns. Okay, so this is the multivariative data. So these variables are known as independent variable, and we have to set the labels. So these labels are known as dependent variable. Okay, so for this first record, a1, a2, a3, an means this is the n dimensional data. The data is split into n dimension. Okay, so we have to put, if this type of data is present in our data set, then this is a class 1 or class 0. Okay, so we have to set the labels. Okay, so this kind of work additional task. Okay, so we have to put 1 for this kind of data. First record we have put 1, for second and third record we have put 0, and for fourth record we have put 1. If this kind of data d1, d2, d3, dn, if this kinds of data is in data set, then it is a positive category. It comes under the positive category, and b1 and c1, second and third row, belongs to the negative category, means 0 class. Okay, so if there are only two dependent variable, 0 and 1, so basically it will be under the binary classification problem, where the classification is made on behalf of 0 or 1, means data belongs to 0 class or data belongs to 1 class 1. So there are only two variables, 0 and 1. If we are providing the labels 0, 1, 2, 3, then it will be our multi-class classification problem. So in supervised learning we have to provide the class labels, and this dependent variable is going to be predicted by the machine. Okay. So for example, the application of supervised is that house price prediction. Okay, so for house price prediction, we have to take some features. These features may be your what is the area of your flat, what is the area of flat, or whether flat in the society has gardens or not, number of rooms. Okay, so these are the features. You have to take the number of features. In the previous slide, even you can see here the independent variable. So independent variable for house protection may be square foot, what is the square feet area, and the second is that house has garden or not. uh, Third is security, proper security is there, and others. Okay, so you have to take some independent variable, and after that you have to put labels. And what will be the label? The price. What is the price of house? If house has all these features, square feet is 1000 square feet, the number of rooms are 3, and the house has garden or not, so we have to set the prices. If among 3 features 2 features are present, then the class label will be different, means price will be different. Okay, so on behalf of in supervised learning, we are providing the labels while we are giving data to the machine. When we are when the machines are going to be trained, then we are supplying the labeled data. So unsupervised learning, as we have previously discussed, that there is no class labels. Machines itself explores and finds the best solution. And the second applications was dimension reduction. Okay, so neural network also, example of neural network comes under the unsupervised learning approach. And third one was reinforcement. Now we are moving towards the classifiers. So before going to discuss classifiers, we have to understand that what is linear data and what is non-linear data, because we have to classify them. We have to classify these data. Okay, data may be in integers, or data may be your text, data may be your some patterns also. So in this first image, you can see the blue dots and black cross. Okay, so if you apply any classifiers, suppose you are applying neo based classifiers on first image, so it will easily separate these two types of objects. Okay, so in this type of data you can use any algorithm. Okay, means less computing algorithm you can also use, and that algorithm will separate the data in 2 parts easily, because you can see that green dots are other sides, and black cross are another side. So it will easily draw a hyperplane between the green dots and the black cross. The problem is with the non-linear data. In this second image you can see, okay, this is the mixed data, where you can see the black cross and red plus sign. So these are the mixed data. Okay, so in between red plus sign there are cross sign also, in cross sign regions there are plus sign also. So you have to separate these data, means you have to put the plus sign into one cluster, and you have to put this black cross into another cluster. So this is a challenging task, that how to separate or how to categorize these types of non-linear items into classification problems. So to do this type of task, we can use support vector machine, we can use random forest, we can use decision tree. These are the powerful classifiers that are able to classify non-linear patterns of data. So in this image you can also see there is a mixed data. Okay, so there are the blue dots and other types of color of data. We can use support vector machines. We can use decision tree and we can use the random forest. Okay. So we can never say that support vector machine is not good or random forest is good. It depends on the data set, that which type of algorithm is achieving good accuracy. Many times support vector machine achieve good accuracy than random forest, but many times random forest is achieving good accuracy than support vector machine. So it depends on the problem and it depends on your logic. So first let's discuss about support vector machine. So the concept of support vector is that it has to create, or it will create, a hyperplane. First thing is that support vector machine is very useful to separate the non-linear data. It is able to draw a boundary line, or it is able to draw a decision line, boundary decision lines between the between these two classes, maybe more, 3 classes, 4 classes, for multi-class classification also. Okay, so support vector machine is able to draw the boundary line between these two types of objects. Okay, so support vector machine will increase the marginal distance between the nearest point. In this image you can see that this blue dot is close to this first line. This is your hyperplane. Hyperplanes, what is the meaning of hyperplane? That hyperplane will tell us that blue items or blue data are in positive side and green data items are in the negative side. So this is the main line, this is the maximum margin hyperplane, this is the main line, and maybe there are items between the main line and this dotted line. There may be item. So the task is that the item will be shifted into the positive hyperplane. Okay, and the negative item, maybe negative item in between hyperplane and this marginal plane. Okay, so the task is that the support vector machine is that type of algorithm which will shift the data towards the positive side or shift the data towards the negative side. So this is the concept of support vector machine. The support vector machine tries to increase the marginal distance between the positive side and negative side. Okay, so that the positive data will shift towards into the positive region and negative data will be shifted towards the negative regions. So so machine will easily classify the pattern of data and whether the data belongs to positive or negative. Second classifier is decision tree classifier. In decision tree classifier is based on if else condition. There are the decision nodes. Okay, if the variable is less than 10, then it will move towards the left direction. If it is false, then it is means the value of x is not less than 10, then it will move towards the right direction. Okay, so like that, if else condition. So decision tree is based on if else condition. So the basic concept of decision tree is about decision nodes. Decision nodes means our moves will be performed. Our moves are performed on base of truth. Suppose the value of x is 12, so it will move towards y less than 0. 12 less than 10, that is false, so it will automatically move in this second decision node where it is written y less than 0. So the second category is decision tree classifier. This is a single you can see that this kinds of representation is of single tree representation. Okay, decision tree, there is a first node is the first node is a root node, then there are various decision nodes, on behalf of condition truthness, the moves will be performed. If we if we collect, or if we use more than one decision tree, if we can use 4 decision tree, or if we use 8 decision tree, so it will form random forest approach. So in random forest classifier, which came in year 2000, so it will take various decision tree, and it will tell the outcome. The outcome will be reported with the majority. Suppose I am using random forest classifier, and I am using the number of decision tree are 4. If I am using decision tree are 4, I am taking 4 decision tree. Among 4 decision tree, maybe 3 decision tree are producing class 1 result, and 1 decision tree is producing class 0 result. So with the help of majority of decision tree decisions, the machine will be able to predict the outcome. So random forest classifier, this is the set of fruits of class. Okay, so here we are using 3 decision tree here, n number of decision tree. Okay, we are using n number of decision tree. So decision tree first, decision tree 1 is predicting apple, decision tree 2 is predicting about apple class, and decision tree, last decision tree is predicting class B, that is banana. So what is the majority voting? So in this image we can also assume that there are 3 decision tree, and among 3 decision tree, 2 decision tree are predicting apple class. So what will be the final outcome? 2 out of 3, means we have majorities. 2 trees are predicting class A, and one decision tree is predicting class B. So this is the majority voting says about final class. It is a final class of apple.
Sir, we should take a break of 15 minutes. Students may also take a break of 15 minutes, and we'll join the session at 11:45.
Okay, ma'am.
Please request, I'll be requesting everyone to stay here at the MS Teams link. And just take a break of 15 minutes, and we'll join at 11:45.
We were discussing about the decision tree, that how it works, support vector machines, what are support points. Support vector machines means support vectors are the data points. Then next, decision tree classifier, and the third is that random forest classifier that came into year 2000. So random forest is random forest produces the outcome on the basis of major voting technique. In random forest, if you are choosing 4 decision tree, and if 3 decision tree are giving positive response and 1 decision tree is generating negative response, then 3 decision tree out of 4 are generating positive response. So the class prediction will be defined by the majority voting technique, as you can see in this slide and discussed before the break. So this is the second slide of random forest classifiers, where you can see that tree 1 is predicting class C, tree 2 is predicting class D, tree 3 is predicting class B, and tree 4 is predicting class C. So here two decision tree are predicting the class C, that the data item is of data item belongs to class C. So what will be the majority voting? So that the final class will be our class C, that data item belongs to class C. Two times means two decision tree are generating the prediction, or two decision tree are predicting about data item C. So random forest is random forest take the combination of various decision tree, or utilize, or you can random forest classifier can choose the various number of decision tree. Now the next topic is about neural network. So this is the fourth category of machine learning algorithms, where the machine can be trained. So machine can be given training, or machine can be trained with the help of neural network also. Okay, so the neural network, what is neural network? Means there are the number of nodes which are known as neurons. So neuron is basically taken from the brain. Okay, brains. In our brain there are various memory cells. Okay, and the brain is our human being processor. Okay, whatever human is capturing the things, or human is visualizing the things, that is processed by the brain. Okay, so neurons are connected, okay, in the human being brain. So neurons are evolved by the human brain, okay, and the based on graph theory concept. So you can see in this slide that neural network is inspired by the structure of brains, and these are interconnected with each other, and we can say that these are nodes. So let's understand this concept by the graph, or image. You can see that what is the simple neural network where the machine can be given a proper training. So this is a simple neural network, and in simple neural network there are only three layers. The first layer is always input layer, second layer is about hidden layer, and third layer is about output layer. Okay, you can increase the number of layers between input and output layer. Okay. So if you are increasing the number of layers, means your neural network is going towards deep. Okay, so what is there is a term deep neural network. So what is the meaning of deep? So input layer is fixed. In input layer you can choose number of nodes, or you can vary the number of node. The output layer will be, if there is one node in output layer, then it is a binary classification problem. If there are two nodes at output layer, then it is a multi-class classification problem. If there are more than two nodes, or more than one node in neural network in output layer, then it is a multi-class classification problem. Means you are achieving, or you are generating the output for multi-class classification, or you are detecting the multiple objects. Okay, and you can increase the number of hidden layers. Okay, number of hidden layers between the input layer and output layer. Here you can see the input layer, the number of nodes are 3. The number of nodes are 3 in input layer. The number of nodes are, how many number of nodes in hidden layer? 4 nodes are in hidden layer, and 1 node in last output layer. So if output layer contain 1 node, then it is a binary classification, means whether it class belong to class 1, or or this object belong to class 0. Okay, 0 and 1. 0 means negative, 1 means positive. Okay, So you can increase the number of hidden layer and you will train your model. Again you will train your model, again you will test the model, and you will find the accuracy of your model. Okay, suppose the number of, if you are taking the hidden layer, if you are taking only one hidden layer, maybe model is generating accuracy of 90%. If you take number of hidden layers 2, number of hidden layers, if you are taking number of hidden layers 2, so maybe accuracy may be 92%. If you are taking increasing the number of hidden layers as 3, then maybe the accuracy of your model achieves 94% or 95%. So this is the if you are increasing the number of hidden layers in neural network architecture, then means you are going towards the deep neural network architecture. Okay, so what is the meaning of deep? I think that you have understood. Deep means number of hidden layers are increased. Okay, so there are various pre-trained deep learning models. Suppose there is VGG 19 or VGG 16, where number of hidden layers are 16. Okay, 16 hidden layers are present. Okay, in pre-trained VGG 16 model. So neural network means neurons, and neurons are presented by the node in the graph theory concept or in mathematical notations. So neural network is inspired by the structure of the brain, and these neurons are connected with each other. And neural network, you can enhance the neural network by increasing the number of nodes, increasing the number of hidden layers. Okay. So I told you that the first layer is input and last layer is output, and it depends on the whether it is a binary classification problem or it is a multi-class classification problem. So in this diagram you can see that the number of neurons are, how many number of neurons are present in input layer? 5. And in first hidden layer the number of neurons are 3, the number of nodes are 3. In the second hidden layer the number of nodes are 2, and in the last layer the number of node is 1. It means if in the last output layer the number of node is 1, then it is known as binary classification, means you are training your machine to perform the binary classification. Okay, so here you can see input layer. Okay, so each node is connected with the hidden layer, with the first hidden layer. You can see here your first node is connected to first node of hidden layer, first node is connected to the second node of hidden layer, first node is connected to third node of this hidden layer, means all nodes are connected to each other. Okay, then there are two consecutive hidden layers. The first node of hidden layer is connected to the first node of second hidden layer, first node of hidden layer is connected to the second node of the hidden layer, means mapping. You can see that all to all mapping. Okay, then after that some value will occur at each node. Okay, in hidden layer computation will be done, means suppose the input is x1 and you have to give some weight. Okay, weight will be taken by default when you will perform programming. Okay, so suppose the first input is x1, okay, and weight is w1. Then in the first node, okay, I am moving the cursor here, in the first node there will be computation w1 into x1. Okay, this is the x2 node, x2 w2, x3 w3, means the summation of all will be computed here. Okay, now you can apply activation function here, or you cannot apply, you may not apply. If you are not applying the activation function means it converts the ranges. Okay, suppose the value is 3.2 and it will map, the 3.2 will be mapped between 0 to 1. What is the meaning of, what is the purpose of activation functions? That it will map the continuous value into the ranges between 0 to 1. Okay, so at each node, at each hidden layer nodes, computation will be done. Okay, and if you are applying activation function, it means you are training your machine more robust. Okay, and machine will always produce good accuracy. If you are not using activation function, okay, if you are not using activation functions, so your output will be same as the computation is made here, okay, in the first node or second node, third node. Okay, so means you are not transforming your real values, or you are not transforming the integer value into the normalization. Here there are, in the last node there are two nodes, output 1, output 2. If in the output layer there is more than one node, it means you are training your machine towards the recognize the or identify the multi-class classification problem. Okay, so it should be clear that what is binary classification, what is multi-class classification. Okay, if in the output layer there are the number of nodes are 2, or number of nodes are more than 1, then you are going to train your machine towards the multi-class classification. Okay, so you can increase the number of hidden layer also. If you are increasing hidden layers, then means your architecture belong towards the deep neural network. Okay, you are applying deeply, you are applying hidden layers deeply for the computation. Maybe the model produce good accuracy, so you have to increase the number of hidden layers. So the structure of neural network you have understood: input layer, hidden layer, and output layer. So what is deep learning means? In deep learning, you can increase the number of hidden layers. Okay, so deep learning is also subset of machine learning algorithm, where you are using neural network concept only. Okay, you are your computation or your processing is based on the neural network. Okay, so in deep learning, when we say what is deep learning means you have to visualize that you have to take input layer, hidden layer, and output layer, and you can vary the number of nodes in output layer according to your application or requirement. So in the input layer you have a number of inputs: x1, x2, x3, and so on. Then there are some weights are initialized by the model. Okay, so this is the internal process. Okay, so w1 x1 plus w2 x2 plus and so on, like that. Okay, there will be computation on each node of hidden layer, then that will be passed to next, that value will be passed to next hidden layer. Okay, and if you are applying activation function, it means your machine or your model will be more robust towards the classification problem. If you are not applying the activation function, that you are going towards the regression analysis. Okay, so continuous variable detection or continuous variable identification is made by the regression. Okay, regression analysis. When the hidden layers are increased, then it becomes deep. Okay, just I have told you earlier. So in this diagram you can see there are four input layer, there are four nodes on input layer: x1, x2, x3, x4. Then how many number of hidden layers you can visualize here? 1, 2, 3, 4, 5, 6. So the number of hidden layers are 6. Hidden layer means the number of nodes in each hidden layer is 5. Okay, you can vary the number of nodes in hidden layer also. You can take here 5, you can take here second 6, you can take 3 number of nodes in third hidden layer, and so on. You can vary according to your model fitting. Okay, and in the last layer you can see there is one node only, so this architecture belong to binary classification problem. So in machine learning or deep learning, in deep learning, what is the difference between the machine learning and deep learning? Okay, when you are training the machine, or you are giving training to the machine using classical machine learning algorithms such as support vector machine, k nearest neighbor, decision tree, random forest, then first you are extracting the features from the data set. and then you are supplying those data set into the classifiers. Okay, so first from the data set you are cleaning the data set, you are extracting the features. Okay, then those features will be supplied to the classifier or to train the model. But in deep learning you are using the neural network architecture, where these architecture will automatically extract the features. Okay, these are the inputs, and these and this type of neural network will extract features automatically. Okay, and at last classification will be made. Okay, so the process is different. Okay, to train the machine, the process of machine learning and deep learning is different. If you are using machine learning, then first you have to extract the features from data set, then you have to supply the features towards the your classifier, whatever you are choosing the classifier. Okay, so now uh, now deep learning is also of two types: supervised and unsupervised. Okay, supervised is artificial neural network, convolutional, recurrent, and self-organization map comes under the unsupervised deep learning. Okay, so means in supervised deep learning, if you are using supervised deep learning, then your features are labeled. You have to, means there will be a mapping of labeled data set also, that will be automatically generated by the neural network concept. When you will prepare the model using neural network, then it will automatically add label. Okay. So how neural network operates? So there are 3 nodes in input layer, or there are n number of nodes in input layer: x1, x2, xn. The number of nodes may be 100, 200, any number of nodes, 512, any number of nodes can be chosen. These are known as unit. Okay, input units. So x1, x2, x3, and this is your, suppose this is your first, the computation is for first node of hidden layer. Okay, similar computation will be for second node of hidden layer, third node of hidden layer. Okay, so this means mathematical expression will be executed on each node of hidden layer. Okay, w1 x1 plus w2 x2 plus w3 x3, whatever the value will come, that if you are using the activation function, then your value will be transferred between 0 to 1. Why 0 to 1? Because you are using one node at output layer. Okay, you are using one node at the output layer. So we can say that it is a binary classification problem. Okay, so your continuous value you will achieve here in this transfer function side. You can see here you will achieve continuous variable. Okay, you will achieve continuous variable that will be transformed into for normalization, and the range will be between 0 to 1. Okay, so this is the basic operation, that how neural network computes. So for every hidden layer for every node of hidden layer, this type of computation will be done, okay, into serial order, and then you have to apply activation function on each node of hidden layer. Okay, if there are 3 hidden layers, then each node of hidden layers, this type of computation will be done. So I was telling about one node of hidden layer. This type of operation will be performed for one node of hidden layer. Okay, how to make classification using convolution neural network. Okay, so in convolution neural network we have two operations: convolution and pooling. Okay, In unsupervised learning, pooling was replaced by dimension reduction. That was done by PCA, principal component analysis. Okay, when we were studying about unsupervised learning, then you have seen that the approach, unsupervised learning approach, is applied into clustering and dimension reduction. So for dimension reduction, the PCA was used. Principal component analysis was used in unsupervised learning for dimension reduction. But in convolution neural network, same thing will be happen, means dimension reduction means you will get important features from the image or from the data set with the help of pooling operation. Okay, so pooling operation is used for dimension reduction when you will use CNN, and principal component analysis algorithm will be used for dimension reduction when you will use unsupervised algorithm. Okay. So CNN, you can see here there is one image. Okay, koala ki image hai. Okay, so you can extract the features, main features. Okay, so you can break this image into various parts, 3x3. Okay, you can choose the, means you can take the number of pixels, how many number of pixels you want to take, 3x3 size. Okay, so this image will be divided into 3x3, multiple 3x3. Okay, and the main important what are the main features? Okay, that will be processed by convolution operation. In this image there are the number of pixels, and you have to take 3x3 kernels, means you have to take some window of 3x3, and you will give some value on 3x3. Okay, so convolve means you can easily understand by the matrix operations, matrix multiplication operations, but it is a you can say that linear multiplication. Okay, element wise multiplication will be occur. Okay, so first step is convolution. What is convolution? Means you are multiplying the image pixels with the window size that you have chosen. If you have chosen 3x3 window size, and you have taken some value on that window, so that will be multiplied with the image pixels. Then after that you can apply ReLU. ReLU is a name of activation function. Okay, so there are various types of activation function, I will cover later. So you will apply some activation function here, convolution operation, then ReLU, then pooling. Pooling means you are means the main important features are extracted from the convolution plus ReLU matrices. Okay, main important features are extracted from the matrix. Okay, and the matrix contains the number of pixels which are obtained by after convolution and ReLU operations. Then again you are using second operation, convolution plus ReLU, on the previous data. So after pooling, you will get new input data. Okay, then again you apply convolution plus ReLU on previous data, that is input for this convolution plus ReLU layer. Then again apply pooling layer. Then after that you have got the features. Okay, so you will convert your features into one dimension. Then you will supply these features for training into the neural network. Okay, so you can see that this is image, convolution, ReLU, pooling. This is one set of operation. Then again convolution, ReLU plus pooling, second set of operations. Then you have apply flatten layer to convert your features which are in 2 dimension into 1 dimension. Then your features are supplied into the neural network for training, means you are using neural network for training at the last. Then after that you will get the result. Okay, so this CNN will be discussed in the next session, that is on Monday, in detail. Okay, so now the important part is about activation functions. Okay. So in this diagram, you can see, suppose you are applying activation function. So you can see this S type of shape. Okay, S type of shape represents that you are going to classify your problem into binary class classification. Okay, so this is a simple node. Okay, simple hidden layer node where you have there are three inputs in input layer. There are three weights, and you have chosen some bias. Bias is to reduce the error. Okay. So A1 W1 plus A2 W2 plus AN WN, whatever the result will come, in that result we will apply activation functions, and there are different kinds of activation functions. I am explaining one by one. After that you will achieve the output. Okay. So before moving to the non-linear activation function, I will discuss linear activation function. Linear activation function means no activation function. You are not applying any activation function concept which will transform the value which will transform or map the continuous value into the normalized value. Okay, so no linear function. There are two types of, you can say that there are two types of activation function: linear activation function and non-linear activation function. Non-linear, there are chances that your result will be better. Non-linear means you are using exponential mathematical concept. Okay, exponent, you are using exponent. And if you are using non-linear activation function, then you are able to derive the function's value. You are able to find the gradient. Gradient is your derivation. dy by dx, df by dx, you have learned from the mathematics. Okay, so what is gradient? Gradient is your derivative. There is integration and derivation. So derivation is for dy by dx, df by dx. Okay, so linear activation function means you are not using any activation function, or you are not using anything to transform the value. And if you are not using the activation function, the gradient is not possible. Gradient, it is a technical term. Gradient means derivation is not possible. Okay, suppose you have some mathematical function x square. So if you are using non-linear activation function, then your x square will be converted into derivative, and that will be 2x. Okay, so the output of linear activation linear function is not confined between range 0 and 1, because there is no transformation, there is no mapping of your continuous variable into the normalized range 0 to 1. Okay, so you can use linear activation function in the case of regression analysis. Suppose this is a formula y is equal to mx plus c. So this kind of task can be used by the regression analysis. But for the classification, you have to use non-linear activation function. Why non-linear activation function? Because gradient is possible. You can derive the gradients, and just due to presence of exponential component, exponential sign, exponential mathematical sign. Okay, so your value will be transformed from any continuous variable into the range of 0 to 1. So in convolution neural network, okay, you can use variety of activation functions. Okay, first is sigmoid. Okay, sigmoid is used for the binary classification at the last layer. Okay, then you can see softmax. Softmax is for multi-class classification. So in the last layer, if you are going to train your machine towards the multi-class classification, then it is a compulsion that you have to apply softmax activation function at the last layer. And if you are going to train your machine as a binary class classification problem, so at the output layer you have to apply sigmoid activation function. Okay. So note this thing, that when to use sigmoid and when to use softmax. These both will be used at the last layer, but your problem will vary. Okay, if you are using binary classification, then you will use sigmoid. If you are using the multi-class classification, then you will use softmax activation function. The formula is different. Okay, then ReLU, TANH, leaky ReLU, parametric ReLU. Okay, these activation functions are used in hidden layer. Okay, note these things, that which types of activation functions are used in last layer and which type of activation functions are used in hidden layer. So TANH, ReLU, leaky ReLU and parametric ReLU. Okay, so leaky ReLU and parametric ReLU overcomes the drawback of ReLU activation function. Okay, so let us understand about sigmoid function. Okay, the formula of sigmoid function you can see here, 1 divided by 1 plus e to the power minus z. Okay, so you can compute the value of, if you are taking the value of z is 100, means if your first node of hidden layer is producing the value 100. Okay, so z is 100, means your the value of z is 100, then what will be the derivation? First you have to transform your value. Sz, you have to apply activation function. Sz is equal to 1 divided by 1 plus e to the power minus z. So 1 divided by 1 plus e to the power minus 100. Okay. Then you can easily derivate, you can easily find derivation of this function. What will be the derivation? Sz 1 minus Sz. Okay. So 1 minus 1 plus e to the power minus z. Okay. So you can see that Sz 1 upon 1 plus e to the power minus z, the range is between negative sign to positive sign. Okay. And this violet color is saying about the derivation of sigmoid. If you are taking derivation of sigmoid function, the range is 0.25. Okay, this is fixed, 0.25. And the sigmoid function, this blue curve, S-shaped curve, is saying about the range is between minus infinite to infinite. Here is last is 1 here, and the blue and this violet shape, means bell curve shape, is the derivation of sigmoid activation function. Okay, and sigmoid activation function is for binary class classification problem. Okay, and the value is 0 to 1, but the derivation of this sigmoid is giving you the maximum value 0.25. And the function output is not zero centered, means if you are getting the maximum value 0.25, so it will update the next unit and there will be no change. Okay, so you are not getting good efficiency. If not zero centered means your derivation, the range of derivation is 0.25, that is very less. Second is that TANH. Okay, the function output is zero centered, means you can easily you can get good derivations of this function. So TANH will be used in hidden layer and sigmoid is used in last layer, the output layer. Okay, so TANH function is used. These are the non-linear activation function. Okay, non-linear activation functions, and that we have to use these functions, and we have to try. We have to put these non-linear activation function in hidden layers. Okay, sigmoid and softmax will be used in the last layer. TANH, ReLU, and the variants of ReLU will be used in hidden layer. Okay, so you have to hit and trial. You have to increase the number of hidden layers, and if you are getting good accuracy or satisfaction accuracy, then stop your training of model. Okay. So function output is zero centered, means derivation is the range of derivation. You can see here. You can see that the blue line is about TANH function, and the violet line is about derivation. So range of derivation you can see here 1. Range of derivation is reaching towards 1. Means you are getting the maximum value 1. So you can imagine 0.25 and 1. Okay. You can also use 0.75, many times 0.75 you may get. 10 minutes. 10 minutes. नहीं, वो upload, I will upload the quiz session, then I will do. Okay, the next is ReLU. Okay. And the next is ReLU. ReLU means rectified linear unit. This is also non-linear activation function. Okay. So you can see here there is no slope. Okay, you can see the graph of this ReLU function. There is no slope. Okay, so it will find the value maximum of 0, z. What will be the z? What will be the value of z? That will be output. Okay, if 0 and if the value is minus 2.5, then what is the maximum value? 0. If 0, 100, then what is maximum value? 100. So you can see that there is no possibility of derivation. So if we are not computing derivation, then we cannot back propagate, and we cannot enhance the neurons value. Okay, that will be fixed, but it is also used in hidden layer. Okay. Then to overcome the ReLU function, because in ReLU function there is no possibility of derivation. If we are not using derivation, then it means there is no change for the further operation. So in leaky ReLU, you can see the formula here. You can see the formula of or mathematical expression of ReLU function max 0, x. Okay. If x is greater than 0, means if you are in a neuron node, value is greater than 0, whatever the value, that will be final value x. And if there is negative value, then the minimum value will be 0. Okay. And what is f dash x? What is derivation of it? 1. And so derivation was not possible in ReLU activation function. So we have put some constraint here in this mathematical expression. You can see here max 0.01 x, x. When you will what is the derivation of it? 0.01, 0.01 x. Okay, what is 0. When you will compute the derivation, the 0.01, 1. Okay, so you can see the graph here. In the ReLU function, there was a straight line, then there was a slope, but no derivation. Here you can see the graph. There is different graph. So this is ReLU, and this is your leaky ReLU function. Okay. So means in weight updation, at every layer weights are updated. So if you are using leaky ReLU, then your weights will be updated and you will get the better result than the previous computation. Then next is parametric ReLU. Parametric means if you can put the value of alpha is 0.01, then it will act like a leaky ReLU. Okay. So parametric, if you will put the value of alpha is 0, then that will be ReLU. If you will put the value of alpha is 0.01, then it will act like as a leaky ReLU. So, and you can also change the value of alpha 0.5, 0.75. Okay, you have to do hidden trial to enhance the accuracy of model. Then softmax layer, softmax function. So softmax function is applied into the last layer or output layer, and it is used for the multi-class classification problem. So you can see the formula of softmax. The formula of sigmoid was 1 upon 1 plus e to the power minus z. And here the formula of softmax is e to the power zi divided by, means suppose you have 4 classes. So in the second part, k is equal to 1 to j e to the power zj. In the last part you have to add all the classes probability, and in the first part you have to take only you have to take only one class probability. Okay, let's understand about the some numerical example. So first you have to understood about what is softmax. Softmax activation function is non-linear activation function. It is applied into the last layer and it is used for the multi-class classification problem. Okay, suppose at the last layer you are getting the 4 value: 3.2, 1.3, 0.2, 0.8. These are the probability of your classes. If there are 4 values are present, means your objects, your image or your data set has 4 objects. Okay, and at the last layer the value is 3.2, 1.3, 0.2, 0.8. So 3.2 is converted into 0.775. 1.3 is normalized into 0.116. 0.2 is normalized or 0.2 is mapped into 0.039, and 0.8 is mapped towards 0.070. So in this continuous value 3.2, 1.3, 0.2, 0.8, you will apply softmax activation function so that you can achieve or you can get the probability. Okay, if you sum the probability of every classes, then the output is 1. Okay, means sum of 0.775 plus 0.116 plus 0.039 plus 0.070, then the probability is 1. The summation of these probabilities are 1. So you have understood, I think you have understood that there are 4 classes. Okay, so you can also see here the maximum value is 0.775. So automatically it belongs to class 1. Okay, you can see there are 4 probability: 0.775, 0.116, 0.039, 0.070. So which is the largest? 0.775. It means that your object belongs to class 1. This is not object 2, this is not object 3, not object 4. This is the recognition of object 1. Okay. So how you have converted? What is the process, internal process behind it? You have applied softmax activation function on this 3.2. So what is the mathematical? E to the power 3.2 divided by all the class probabilities: e to the power 3.2 plus e to the power 1.3 plus e to the power 0.2 plus e to the power 0.8. Then like that you have achieved the probability, or this 3.2 is converted into 0.775. Okay, that is the largest number, so it belongs to class 0. Okay, because it has highest probability, so the object will belong towards class 0. Okay, so this is about the softmax activation function. So in this session we have understood what is machine learning, what is purpose of machine learning, what are the basics of machine learning, then the machine learning types, that what are the various ways where machine can be trained. We can give training machines. Then we have understood the important classifiers, supervised classifiers. Then we have discussed the neural network and deep neural network. Okay, what is a neural network? What is deep neural network? Then we have understood linear functions and what is non-linear activation functions. Linear activation function is like a perceptron. Okay, perceptron is basically, if you are not using the linear activation function, then it is a kind of perceptron and used for the regression purpose. Okay, and non-linear activation function, and in non-linear activation functions you have studied Sigmoid for binary classification, softmax for multi-class classification. These
Hello,
both
Basu sir.
Sigmoid and softmax are used in the last layer. Then you have understood about the TANH, ReLU, and parametric ReLU and leaky ReLU. Okay. So in today's session, I think that you are able to understand the basic concept of machine learning concept. Okay.
मेरा क्वेश्चन आपको सुनाई नहीं दे रहा
I have put this. I have put this.
है
So
Excuse me, Basu sir. Hello, Basu.
yes, sir.
Sir, please again define the function of normalization. You have normalized the value. So whether we have to use function.
Hello, hello, sir.
Yes, as you have converted this, the sum of possible classes of the outcome must be 1. So here you have mentioned 3.2, 1.3, 0.2 and 0.8. Then you have converted this value. So how we will convert the value, whether we have to use the predefined function or
Oh, when you will put at the last layer softmax because there are four value means there are four objects in one scene or there are four objects in one image. Okay, so we want that which kinds of object has most probability or which kind of object is present in the image.
okay.
So
And sir, what? Yes,
so,
sir.
sir,
Yes, sir.
please listen. So there are four classes, and at the last layer, these numbers come after the hidden layer, 3.2,
And
1.3, 0.2, 0.8. Then we have to convert this number into probabilities because because we are normalizing the ranges of these numbers into 0 to 1.
okay, okay. And sir, this the meaning of the last statement, the sum of all possible classes oblique outcome must be 1. That is for this now 0.775, comma 0.116 and 0.039 and 0.07. The sum will be 1.
1, yes, yes, sir.
Okay.
And you can compute softmax 3.2 if you are applying softmax 3.2 in first node, that is the value of first node is 3.2, then
Okay.
how it is computed e to the power 3.2 divided by all the continuous variable.
Okay. So,
And
sir, can we use instead of this 3.2, can we use softmax 0.775 or no?
no,
Only
no,
we have to use
we are
the
normalizing or this is activation function. Softmax is activation function which will transform the continuous value into the normalized number, that is 0 to 1.
okay, sir. Okay. Thank you, sir.
And in four classes, if suppose the second class was suppose 3.8, the
Okay.
second object has continuous value 3.8, then definitely 3.8 will be higher than 0.8. So the probability of second object will be more. The probability
Okay.
of second object detection will be more.
Okay, sir. Thank you,
And
sir.
but the outcome the sum of probability should be 1. So if the second class is 3.8 and the it will transform into 0.8, then automatically 0.775 will be reduced
Okay,
because the
sir.
sum of
Thank you.
probability should be 1.
Okay, thank you, sir. Thank you.
Yes, sir. Thank you, sir. So thank you, dear professors and staff and dear students for today's session. And if you have any doubt, then you can call me or you can you can write in chat box